Hello everyone, this side Rohit Gupta. I am from Jaipur, Rajasthan. I am currently pursuing my Bachelor of Technology from Chandigarh Group of Colleges, Janjeri, Mohali. I have 1 year of experience in physics in Czech. I have working last since 1 year in Czech, so I have a good knowledge in the physics. I have a hands-on experience in the physics. So guys, today we are to start our most important topic, modern physics. So you know what is the modern physics? We will start from the very basics. Modern physics is the study of the physical phenomena that occur at the subatomic scales as well as vast scales, speeds and energy. You know what is the physical phenomena that's occur to subatomic scales? Okay, it is the foundation of the branch of the physics such as quantum mechanics, special relativity, general relativity. Okay, modern physics that is based on the two major breakouts of the early 20th century like relativity and quantum mechanics. Okay, this is the basic definition of the modern physics. You can write if you are asked in the paper. Okay, so now we will start modern physics. One important topic in modern physics, photon, that's the quantum of light. Okay, so before starting about the photoelectric effect, photon effect, we have to know how it is developed, how it is, who is developed the photoelectric effect, in which sun it is developed. Okay, so in 1905 Einstein proposed that electromagnetic radiation or light is made up of photons. Okay, like we can say that in 1905 Einstein, who is a great scientist, that is proposed and that electromagnetic radiation or light made up of photons. He's generalized that a electromagnetic light or radiation of the ray that is made up of photons. Thus the photon is the elementary element of the light, or light is made up of photons. So is this line mean that our light, light is made up from photon. The photon is the elementary element, is the first element that is made by that light is made up for the photon, and light is made up of photon. So okay, so Einstein showed that light energy is not emitted continuously, but it is emitted individual amount of energy called quantum of energy. Like Einstein show like this one energy is not emitted continuously, but it is emitted individual amount of energy. That energy name is quantum of energy. That's clear. Okay, now the question is, what is the energy of the photon? How we can identify energy of the photon? What is the energy of the photon? How we can calculate the energy of the photon? So according to Einstein, each photon of the light wave frequency has energy E, is given by E means energy of the photon, H means Planck constant, that's value is 6.62 and 10 to the power minus 34 joule. We can call it nu, frequency of photon. This is the formula of the photoelectric effects energy. Okay, now we move forward on the properties of the photon. So now we have to know about this, what is the modern physics for photon, what is the energy of the photon. So now we have to know about the properties of the photon. So we should know about the what is the property of the photon. So we'll start. What is the photon, like how is the photon work, and where we use the photons. So all this property will be covered in this property, all things will be covered. Okay, so photon does not have any mass. Understand, a photon, the like light is made by photon, so this photon is not made by any mass. Okay, photon does not have any charge and are not deflected in electric field or magnetic field. That means the photon that not have any mass, so that is not have any charge or not have deflected, means it is not we change their direction in any photon that not change their direction in electric field or magnetic field. Okay, all the quantum numbers are zero for a photon. Okay, so in the empty space the photon moves at speed of light. In the empty space, like a room where no one is there, so if we can run the photon that moves at the speed of light. It's, you know what is the speed of light? The that is moves same as the photon speed in the empty space. Remember this important point. Okay, in the interaction of the radiation with the matter, radiation behaves as made up of the particles called photon. That is the definition of the photon, you can remember it. Okay, the energy and momentum of photon are related as followed: E equal to pc. That is the formula of relation of energy and momentum of the photon. P is the magnitude of momentum and c is the speed of light. Photon is called virtual particles. Okay, the energy of a photon is directly proportional to frequency and inversely proportional to wavelength. That's the important point that we will cover in the next. So now we will cover all the properties of the photon. Now we will move forward on the photoelectric effect. That is main important topic in this part. What is the photoelectric effect? Okay, when a beam of light sufficiency high frequency on a clean metal surface light, then the light will cause electric to leave the surface. Okay, definition: the phenomena of the emission of the electrons by metals when they are exposed to light of suitable frequency is called photoelectric effect, and emitted electrons is called photoelectric. Okay, there's this very simple definition is given by the Einstein, that the phenomena of emission of electron, like emission of electron means we have to we have to given the electrons in a particular part, you know, and metals, like electrons when emitted on a metals, they are exposed light, means they are export the light at suitable frequency, that is called photoelectric effect. Okay, so now the question is that how the photoelectric and construction are working. What is the scene behind and how it is working? So we will start with the construction of the photoelectric effect. So construction, the Hertz experimental setup used to studying the photoelectric effect is shown in the figure. That is shown in the figure that this light is come on this metal, and then metal is converted metal plate, that is negative charge converted the photons in the photoelectrons. This metal is converted connected into emitter. Okay, and this is negative charge, positive charge, this is positive collector, and this is negative plate, and this one is the light. Okay, the setup consists of elected glass tube, photosensitive metals, plate C, another metal plate A shown. Okay, I already told you this metal plate, this one metal plate, photo light, photo tube, and collective positive. A monochromatic light source emerging from source as sufficiently short wavelength enters in the glass window W and fall into photosensitive plate C is called emitter. This one is light is emitted from this one, and uh, this light is connected from this emitter. Okay, so now it is the working of the photoelectric effect. When a beam of light fall on the photosensitive metal plate C, which is called emitter, that I already told you, this one is the emitter. Okay, the plate C emits the photoelectrons due to photoelectric effect. The photoelectrons emitted by plate C will be attracted towards the positive plate A. Okay, and these electron flows in internal external circuit. Case of electric current in circuit such as current is known as photoelectric current and measured by micrometer connected in the circuits. Okay, this one is the circuit that is emits the photoelectron due to photoelectric effect, and the photoelectric emitted by plate C and positive from plate A. Okay, this one is two plates, plate C, plate A. Okay, so this one is the large photoelectric apparatus. This arc lamp is going to from prism and monoelectric lights. This one is architecture of the photoelectric effect. Okay, so guys, now we will discuss in another session. For today you have to revise all the concepts, and we will start from the next one. Thanks everyone, thank you so much.